manager within the DGT's IT unit. So he is the person who is actively trying to put out of jobs. So I hope he will tell us how and why. Szymon, the floor is yours.
Thank you. It's a pleasure to be speaking to you from sunny Luxembourg, and I am here to discuss exactly what was already mentioned and do a short introduction, that is the views and expectations towards machine translation and especially neural machine translation. And in order to illustrate this, I like to start with an anecdote. Can you see my presentation on the other side?
Yes.
Yes, good. This is a picture of a human eye. It's the blood vessels at the bottom of human retina. And if you go to an eye doctor, right now you will have a picture taken and you can have it scanned for symptoms of disease. How is it done? Well, basically it will be done by a computer program. It will be done by a so-called neural network. And the way it works is basically you have a computer program that is trained on photos of patients that were previously diagnosed, and this computer program will flag photos showing symptoms of diseases, like for example glaucoma. And then of course the doctor will review it and will give you the final diagnosis. And of course you may think that this is completely irrelevant when we are talking about translation, but more or less, this is where translation is going right now. As you said, I am one of the people who joined the dark side. I am one of the people who introduced computer tools into translation, but basically it's not like the tools can replace human beings. And this analogy with doctors who analyze the picture of human eyes allows us to understand it. Why? Because computer programs are very imperfect, and I like to start my presentation reminding everyone of the limitations of computer technologies. And this is why, both in machine translation and in analyzing pictures of human retina, it is necessary to have a human to make the final decision. A doctor will make the final diagnosis, and a translator is responsible for proofreading the output of machine translation and making the final decision of whether this is a correct translation or whether it needs some further editing. This is how translators are currently supposed to work at the European Commission. Therefore, we like to say, jokingly, that translators are like doctors now, analyzing what the computer has already analyzed and making the final decision. The important part here is that translators and doctors have the final say. You cannot rely too much on the machine. Why? Basically, machines make mistakes, computer programs make mistakes, and there is a lot of misconceptions about the possibilities of modern technologies, and it's important for translators and anybody interested in translation to understand this. So let's discuss it for a moment. We have now a whole revolution that has to do with machine learning, self-learning computer programs. For example, I have here a picture of Google car that is trying to drive without a human driver. However, I have to replace the picture because previously the photo showed an Uber car, and Uber car was involved in a car accident killing a pedestrian, which I think quite well illustrates that this technology still has vast limitations. And the thing to remember about machine learning and the results of machine learning, which we call artificial intelligence system, is they are trained to perform very specific tasks. learning. It is directly relevant for translations, for translators, and anybody interested in translation. Why? Because machine translation is also based on technologies that do not attempt to understand the text and that don't have any kind of general knowledge about the world we live in. There is a number of misconceptions about all these technologies and all these notions that we use to describe these technologies, and I like to remind everybody that machine learning is not really about machines, it's about computer programs. That artificial intelligence is not really very intelligent, that so-called deep learning is not really that big, and the neural networks that we use to perform machine learning have very little to do with actual neurons. But most importantly, for everybody interested in translation, machine translation is not really about translation. So, what are these things really about? Machine learning is basically self-learning computer programs that learn from statistical analysis of data. It can be photos, it can be, for example, past translation, parallel text. Artificial intelligence is basically using statistics and symbols to simulate intelligent behavior. And deep learning is machine learning that uses several layers of processing. And neural networks are computer programs that are capable of learning from data which are more or less inspired by neurons but don't have much to do with biology. And this is very important because the metaphors we use shape our worldview. At the European Commission, we have many people who are afraid that these technologies will somehow replace translators, when the aim of our project is to have computer programs do the work that humans are doing. And this is against our philosophy. Our philosophy is that machines, computer programs, are supposed to augment humans, make them more efficient, but humans have the final say. Humans have to make the final decisions. And it is important for us that our translators understand that machine translation is not really about translation per se. I don't want to get into a philosophical debate, especially when speaking to a room full of researchers and students, but to me, machine translation is more or less rendering the meaning. This is into the target language. This is not what the machine translation system is doing. It is just using statistics to guess the likely equivalent in the target language on the basis of past translation. So basically what the machine translation system is telling you is what is the most likely equivalent, but it is not trying to understand the text and to perform any deeper analysis in the sense of how linguists understand it. It is not trying to understand the grammar, for example, and make decisions on the basis of grammar. And this is important, and this has consequences, because there is always a lot of hype about machine translation, and many times in history, it's already happened that machine translation systems have better reputation than they deserve. They are slowly getting better, but they are not as good as people claim them to be. That is, neural-machine translation, the new technology of machine translation system that is currently introduced within the European Commission, but also by Facebook, by Google, by Microsoft, by other major players, is much better than in the past. But it still has limitations, and it is important for translators to understand the limitations. And this slide illustrates this. It basically, somehow, in a naive way, it tries to capture the phenomenon that every time machine translation systems get better, people have unrealistic expectations about them. That always, very often, the red line is higher than the blue line, that the expectations, the high, are bigger than the reality that what machine translation can actually deliver. Therefore, when we think about machine translation, the philosophy we apply at the European Commission is this. Machine translation is not about understanding the meaning of text. It's about using fragments of word translations. You use statistics to view the And translators should not think of machine translation as a translation system. Because when they think of it as a translation system, they are very often disappointed by how imperfect it is. They are disappointed by the errors it makes. There are plenty of mistakes there. They should think about this. We encourage them to think about this as some kind of mutated and dynamically adapted translation memory. So basically, it's like a translation memory, all past translation that we have stored, coming alive and changing to adapt to form new sentences. But it will still contain mistakes, and this doesn't mean that it is useless. Machine translation can be very useful for a translator, for editing, for post-editing, even if it's not perfect. Even if you have to correct many things, even if you have to remove half the sentence, even if you have to change the grammar or the word order, it can still save a lot of time as a translator and enhance your productivity. That's why at the European Commission, we see machine translation as indispensable tool in translators' arsenal. But translators need to understand the limitations of machine translation. So, the context of why am I speaking about this? Because within the European Commission, we've had for a long time a project called NTFC, Machine Translation of the European Commission. We are building our own in-house machine translation system. And since November 2017, it has been transformed into e-translation. And there are two important things that change here. Firstly, the new system is no longer intended only for e-officials, but it is also now intended for national public administrations and, for example, ENT universities, European Masters in Translation. Secondly, the new system in translation offers, among other things like we use the interface or faster infrastructure, it offers for the first time access to neural machine translation, to the new technology, machine translation based on neural networks, which offers much better results. And the system is available if you have so-called e-login to everybody who works in public administrations or works for an university or participates in European Masters in Translation. And just to offer you a glimpse, and I don't know how much of this slide is visible on your side.
Yeah, we can see it.
You can see it. I'd like to offer you a taste of the differences between the new machine translation system and the old system. Here you have a sentence written in typical European Commission legalese in English and a translation in German. If this translation was done using the old machine translation system that uses statistical machine translation. If you analyze it carefully, you will notice that it is grammatically incorrect. Especially the second sentence is completely wrong word order, and some of the declensions are completely off. With the new neural machine translation system that we are introducing, you will get a grammatically correct sentence with correct declension and with correct word order. However, the new system also has limitations, and they are, I think, best shown by the fact that you will have words disappearing. In the original sentence, there is the word continue, and in the other sense, I'm sorry, I have one word in both. You will have forsprengige integration, but in the new sentence produced by the new neural machine translation system, this word has completely disappeared. So the new system still does not produce completely perfect translations. However, I assume that the conference in Warsaw also used more relevant example that is encouraged. Once again, we have a sentence in English text that is the original, and a Polish statistical translation. Have you noticed that basically it is, once again, quite incorrect grammatically and stylistically? And then the neural machine translation is much better. The language is more polished, the language is more natural, more dramatic. However, there is one problem here. This neural machine translation system is quite flexible with words, and it treats the name NERE as a synonym of the supposed to end in a few years, and then this will not be correct translation. And I use this example to illustrate the neural-machine translation, why it can be more fluent, more idiomatic, more natural, more consistent, and more grammatically correct, makes mistakes sometimes because exactly it is more natural, more fluent, and tends to produce nicely sounding sentences, but it can lose some accuracy. It has, for example, the tendency to replace the word of their synonyms. So a translator working with it has to be aware of the limitations, has to be aware that neural machine translation, as perfect as it may seem upon the first glance, also has limitations and can contain mistakes that can really distort the meaning of the original text. And to understand this, I think that the best comparison between the kind of errors you can find in neural machine translation and your statistical system, I use this example. If you have a standard German sentence, which they took a lesson, and you have a human translation, I want to indicate, from the old statistical machine translation system, you can expect various types of fluency errors. That is, errors that are mostly about grammar. I don't think each is a completely incorrect sentence in English. However, with the new neural machine translation systems, the one that we deployed, the Commission, the one that are deployed with Google and Microsoft, you can more frequently expect adequacy errors. That is, errors that are not about grammar. The sentence will be correct, but it will be distorted in the sense that it will not really correspond to the meaning of the original. Therefore, you will get the correct sentence, I want to eat chicken, but chicken is not the correct translation of the German word kuchen, and it was inserted here by accident. It was a mistake, and this is something that translator will have to correct. But in practice, it's important to say that neural machine translation is a system that takes the old system took into consideration just the local context, just a few surrounding words. The new system, when translating, takes into account the whole sentence. Every translation decision, every decision that the system made is based on the whole sentence, and thus it is more consistent. And also, neural machine translation is capable of learning from the same amount of data the grammar of languages. And it is important in the case of languages like Polish or Lithuanian, which have rich declension patterns. We call languages like this morphologically rich languages, as opposed to, let's say, French or Spanish or Portuguese or English, which have relatively limited morphology. Basically, neural machine translation will produce much more consistent and much more grammatically correct sentences because it is able to learn more from the same amount of data. Data, of course, being past translation, parallel translations from the past. However, neural machine translation is not artificial intelligence in the sense that it is not really intelligent, it is not aware, it doesn't understand anything. It doesn't allow us to replace translators with computers. It's just a more efficient version of a statistical system, really. A system that is capable of producing grammatically correct sentences for many languages, but still makes mistakes because it doesn't understand the word. It doesn't understand, for example, to go starting with language pairs with the lowest relative quality. And lowest relative quality means we mostly translate from English and into English, so lowest relative quality we usually encounter when dealing with translations that involve German, the Finnish languages, and the Slavic languages, because these are all languages with relatively rich morphology. Therefore, we started with German, Hungarian, Finnish, and Estonian, and then we are working now on Slavic languages and Baltic languages, and Irish. And these are our priorities for the time being. Next, of course, will be the Romance languages and the remaining Germanic languages. So, in practical terms, what we tell our translators is this. Neural machine translation compared to the old statistical system offers a trade-off. That is, translations will be more polished, more correct grammatically, stylistically, will better form, more dramatic, better sounding, but they can be inaccurate. And when they are inaccurate, they can be misleadingly inaccurate because everything else will be correct. It is much more difficult to stop in a mistake in a sentence that is otherwise very correct grammatically. So translators need to be vigilant when working with neural machine translation. We hope that neural machine translation will make differences of quality between machine translation smaller, because our biggest problem so far was that machine translation was very useful for some language pairs, like for example English Portuguese or English French, but very useful for other language pairs, like for example English Hungarian, Polish being somewhere in the middle. That is, it was useful, but not as useful as for other languages. And it is important to know that neural machine translation is a very expensive technology because it requires special hardware, it is costly, so when only necessary. We can very much imagine that in some cases we will still stick to the old statistical machine translation system. But the message and the philosophy of the European Commission is this. When it comes to machine translation, the future of translation is prosperity in machine translation. Our policy is to convince our translators that they have to use machine translation very, very well. It doesn't mean that they have to do it always. It doesn't mean that they have to do it using for every type of document. But if they are not using it at all, this is a bad attitude. They can be much more productive if they use it with many documents. And that's it. Thank you very much.
Thank you, Szymon. There is an applause. I don't know whether you hear it. Thank you very much.
Yes, I can hear it.
Thank you for talking to us, and sorry about the initial technological difficulties. I'm afraid we don't have time for any extra questions for you, but if there are any questions later on, I will pass them on to you so you can have a say. Thank you, and have...
And I will be really happy to answer. Thank you very much.
Bye.
Bye.
Okay, I hope those switch off by itself. So let's move on to our next speaker, Dr. Agenor Hofmann-Delbor. This is a very difficult name indeed. I hope I did well.
It's easy to pick a RPG game nick when you are Agenor.
Yeah. Our next speaker has a PhD in information technology. He's a founder and managing director of Localize.pl. You can go online and have a look. Judging by the description, he has also a great sense of humor. So he's been involved in translation industry for many years, since 2003, in many roles as localization engineer, localization tester, certified trainer, also translator, IT manager, project manager, research and development director, sales director, and many, many others. So he is a person of many faces. He is also a founder and published author of Helion Publisher House and a book on software localization in Polish. He's an originator and organizing over 15 large conference events, including the Translation Localization Conference and Konferencja Tłumaczy, and he'll be talking today about the past, present, and future colliding when it comes to translation technology.
Thank you for the introduction. Most of all, thank you for inviting me. It's an honor to speak here in Warsaw. And the first question I have, I know we are running a bit late with time.
20 minutes.
20 minutes, okay. So the introduction is already a thing of past, but today we heard some great speakers talking about the context of technology. And this is exactly what I would like to follow up on, because we tend to see our translation industry as a separated bubble from the other industry, something that's separated from the other industries. And looking at the bigger picture sometimes allows us to understand that each technology we are using was actually inherited from other domains, other industries, and our daily life standards. And that's exactly what I would like to address today. And of course, each translation conference needs a St. Jerome reference. We already had one today, but why not do it again? Of course, I'm mentioning the founding father of the industry, just to show that for many centuries, the working environment of a translator was actually very similar to what he did back in the days. And he already had a cat, if you can see. His desktop was pretty much analog, but you know, he already had a translation project with very long deadline. The project took 25 years to complete. So I'm guessing this will not happen again, but who knows? I'm here to talk about standards and show you some pictures of Summarize, because some of the daily standards we are surrounded with were developed in very strange conditions or very unusual situations. And we accept them. We use them for decades, even centuries. And even translation industry is full of standards like that. So I will show you two pictures. One is the samurai, and the other one you probably recognize, Napoleon. And the standards I would like to address here is driving on the left side of the road or right-hand side of the road. So in general, in Europe, we had for centuries, we had a rule of walking, riding, and driving on the left side, introduced by, of course, the Romans. And what have the Romans ever done for us? They built roads and the aqueduct, of course, but the roads they built were the foundation of our civilization, of course, and the existence of roads allowed us to build technologies that we see today. And this samurai was an example of standards that were introduced artificially, but they were required to for other reasons. As you can see, the samurai has a sword, and it is pointing towards the left direction. If he carries it this way. And the roads in Japan back in the days were pretty narrow, and as you know, samurais were very proud warriors. So if two samurais met on the very narrow road, someone had to, be the one to pass first, and many conflicts arise from that. So one of the shoguns introduced a law that to avoid conflicts, they would simply be walking on the left side of the road. That's why it was simply safer for them to pass. And Napoleon had several reasons to introduce right-hand traffic in Europe. One of them was that he was left-handed. So it was simply easier for him. And now 70% of countries worldwide are using the right-hand side traffic. And in translation industry, we have several examples like that. And in general, history has a funny way of repeating itself. We have some technologies that were introduced and then forgotten. Now we go back to them. Now, I mentioned industry standards in the translation area. Of course, the most popular machine and invention that is all around us, but we are not aware of it, is a typewriter. Typewriter is, for those who haven't seen it, is a machine that allows you to print characters on a piece of paper, a bit like a printing press. So we have a set number of characters, set font, set size. So each typewriter is only able to insert a number of characters onto the piece of paper. Exactly 1,800 characters per page. And of course, from this we have standards. A typewriter was developed in the 18th century and it's probably not used in the industry for the last maybe 20 years or so. So the number of characters per page, the standards we commonly use, is based on the machine that is no longer used anywhere. And because it made sense back then, because if you have to press white space or any letter or number, you put the same effort into inserting the character onto the piece of paper. Now, of course, we have formatting, we have different font sizes, margins, all the other elements of text that were not possible to insert using a typewriter. And of course, because the typewriter was connected to the effort of the writer or translator, the billing was traditionally based on the target text, and we are still using this approach. But you would see the solution is to forget about characters, because we no longer focus on characters, we focus on words or meaning and things like that. So why don't we use words per page as a reference? Well, it's also based on the typewriter. So if we talk about the 200 words per page per page standard, it's also based on the typewriter. And as you know, typewriter is also inherited into the editing software of today. Microsoft Word, any editor that you use, any computer, any operating system, if you edit a file, you have hidden characters that are not visible to you directly. One of the characters is called CR. It's called carriage return. You don't have any carriage in the computer, but you did in the typewriter. So it allowed you to move to another line. And this symbol is still a basis of each file system worldwide. So 18th century is pretty much part of our daily life. And of course, I'm here to talk about technology. And technology has a funny way of returning in a modified meaning or modified approach. 20 years ago, we had a very popular inventor called Dean Kamen. He was a sort of Elon Musk of these days. And I remember press releases saying that the new invention that will show up in a month or two will change the world. We would have to rebuild our cities. We would have to change our way of living dramatically. And everyone believed that, because it was the hype for this new technology was, I'm pretty sure it was bigger than anything that Tesla did or SpaceX did or anything like that. Then the technology he introduced was introduced. And does anyone know what technology was that? Dean Kamen, what he's famous for? Segway. We were supposed to rebuild our cities because of segways. And of course segways were quite successful, but they didn't end up the way we expected it. And it's very similar with technology. Some of the technology is has a funny way of returning in a different shape that we expected. And with translation technology, it is based on measuring the contents of the documents, of understanding what we are actually processing. The very obvious fact of the technology is that it refers to the idea of text similarity, which we were aware of even before the technology existed. We knew that documents are similar to each other in many ways. So then the technology allowed us to measure the hidden content of the document, margins, formatting, white spaces, etc. And because we were able to track these changes to understand what's really hidden in the document, we were able to find new ways to calculate to measure the content of the document. So we based many of the projects billing on words and skipped the white spaces because white spaces were no longer linked to an effort or job you need to do with typewriters. So that's why we run analysis, and this example shows 4 words, 17 characters, because white spaces were not included. And of course, there was a way to estimate the number of characters, including white spaces, if we sum up a number of words and the number of characters. So this was just another way of introducing a standard based on the typewriter, but not directly. And of course, the latest technology, CAD tools, I would say we have 3 generations of CAD tools. We had 3 generations. The first generation was based on the growing popularity of databases. And as we know, databases have two main features. It's able to store information and grow in time, and it allows you to search the information far more quickly than if you do that manually. And of course, when we had databases, the first generation of CAD tools allowed us to run something that's called fuzzy matching. So splitting a segment or a sentence into several parts called tokens, or this was stored in the TM, so the database, and then if we found it in a next sentence or in a next document, in any section of the document that's following the part that we already added to the TM, it was automatically inserted in the document. And the new part of the technology was that it was also able to find partial matches of the analyzed fragment. So we had something that's now called fuzzy matching. We adapted a standard that's based on the percentage to show us if it requires significant effort to edit. So the idea was to analyze the documents before we start, to measure the effort before the work actually starts, based on the similarity, and then we received pretty nice looking table analysis or grid that's supposed to be a good idea of the amount of work required for this specific project. So what we see here is another standard, artificial standard, that was supposedly part of some research project. I couldn't find any research project on this, but the so-called fuzzy bands, you can see they've been around for good 20, maybe 30 years, and basically all CAD tools are now using this set of types of matches, the categories that split the matching to 50-74%, 75-84%, 85 to 94, etc. So this is just a form of an agreement. It doesn't make any difference if we have a fuzzy band that's 82 to 92%. It's just one of the ways to have set categories, set standards for analyzing the contents. Of course, it's an artificial standard, one of the many standards that we are using that no longer or in any way reflects the actual content. It simply allows us to have some standards understandable for all parties involved. So the next generation of CAD tools was changed the idea of the editing process mainly, because the translation memory, the database, it basically stayed the same as in the initial version. So the second generation of CAD tools introduced the concept of converting the source documents into a translatable format, then translating it into in the so-called work format, the bilingual format. In this case, we are thinking about the XLIF-based formats, and then saving the target formats in a same file version that was sent to us by a customer. Now, the second generation also changed the way we work with resources. They allowed us to connect to multiple TS, multiple resources, even translation engines. So now the translators didn't have to work with one single large TM. He was able to select the source and then type his translation or start editing the fuzzy match he received. Now, also the second generation introduced predictive typing, something we knew already from other areas of our life, from cell phones, where the computer, which is exactly in our smartphone, allowed us to type our messages faster by guessing the words we are trying to type. And the same is with the second generation of CAD tools. They try to speed up the process of typing. And of course, then came the next generation. It's difficult to say if it's already the third generation or generation two and a half, but repairing matches is something that went beyond the initial concept of the CAD tools. So we were now able not only to have several sources of fuzzy matches, but to fix them in a smart way. The tool was able to combine several matches into something that requires less effort to edit than before. Of course, I'm talking about technology, but CAD tools was just one of the technologies on the translation market that was relevant for translators. Around 10 years ago, hype that we have for NMT was pretty similar to the hype that was for the SMT. So when SMT was introduced, a new term was also introduced, post-editing, we mentioned earlier today. And of course, post-editing is only possible when someone is watching. The big brother is the concept of measuring the effort the translator, the effort that is translator's effort for fixing the machine-translated content. So there are two ways to measure it. Of course, we can measure it by tracking time, or we can do a more detailed analysis just to check what was changed from what to what was the target translation, etc. So in general, it's about measuring the effort of the translator. It's no different than measuring the similarity of text and fuzzy matching. It's just another approach, but post-editing requires this. Requires checking productivity, requires checking productivity per editor, time spent on a sentence, and it's average throughput from the project manager's perspective, and things like edit distance, and so on. But what we are addressing today is mainly neural machine translation. We had several presentations today on this topic, and of course it's already here. It's a technology that's probably overhyped, as you've seen today, but it's already part of the market. And my view is that we no longer can talk about NMT using the post-editing phrase because it's a different approach. It requires a different approach. As you've seen, it creates a completely different content, and since it's already part of this market, we need to learn the way to measure the effort, and something that's called the machine learning. The easiest way now is to check what's the analysis before we do anything. Then we start to translate, and then we rerun the analysis after several segments to see if the engine was able to make some progress after our corrections, our editing. So, of course, the only way to, in the end, to measure the effort of the translation is of the translator is to measure time spent on the task. So what we can expect is the higher. Okay, just the last slide. So that's fine. So we can measure the time. We can measure the output. That's the number of words we are able to translate daily or monthly. But if we try to assign a different approach to measuring the effort of translator, we may not find a suitable way to do that because of the specifics of the NMT. So looking at the technologies, we've seen several generations. We've seen some technologies that were part of the other industries, like smartphones, like editors, etc. But we also need to look at the cultural aspects of the technology. Technology is always developed for a specific reason, and most of the technology we are using was not really invented in the translation industry. We somehow adapted it to our needs, and that's what's probably going to happen in the future as well. So we need to look closely at technologies from other domains, other industries, because they will be at some time part of our working environment. They will be part of the content of we translate. So looking at other domains, other technologies is important, and also looking at languages of the economy, of the world economy. We need to see the changes that are already happening, and probably think about the future of our working language pair. This probably also connected with the technology we're using. So sorry, this is the last slide, so I will just move quickly with my bullet points. I know the lunch, being between the lunch and is.
Yeah, you were talking about cakes. I think.
Yeah.
I'm hungry.
So I promise this is the last slide, and then we can go for lunch. My view is that we can expect AI in domains that we don't expect AI to be applied to, because it always happened like that. It's part of the current version of the AI, especially neural networks, have a very interesting way of using the same methodology for different domains. So maybe a system efficient and at recognizing patterns in one area is very easy to move to another area we didn't expect it to be applied to. So more AI in our life is definitely going to happen, and probably sooner than we expect. We can also expect some further developments in the editor of CAD tools, so we can type faster, get more matches, fix the suggestion from the TMs better, but there is not much space for improvement anymore. We are pretty much getting to the level of to the amount of text we are able to read. There's a limited amount of text we are able to read, to check, and we have our limitations, not the technology. It's so that the limitations of the CAD tools is actually a limitation of a human eye, human brain. To some area we cannot really move beyond a certain point. So a bit some changes in the editing, but probably evolution rather than revolution. Automation, more